directly in either the Apache Hadoop distributed file system or any other data storage system such as the Apache HIVE. So Hive is now maintained by the Apache Software Foundation. However, it was initially developed by Facebook due to the scalability and cost effectiveness of the Hadoop ecosystem in processing large sets of data. Additionally, it also allows user to write SQL-like queries, the HQL, to extract data from various databases and any files integrated with Hadoop, and then it's converted into MapReduce queries, allowing the queries to communicate with the Hadoop ecosystem and the HDFS. And the next one, the advantages of Hive. Firstly, it can be used for online analytic processing, and it is also scalable, fast, and flexible. And also, as I've mentioned before, it is a great platform for the SQL users to write SQL-like queries to interact with the large data sets that reside on the HDFS file system. However, on the other hand, we also have the disadvantages of Hive. Firstly, it's not a relational database. It can perform online transaction processing, and it cannot be used for real-time update or queries. And lastly, it cannot be used for scenarios where low latency data retrieval is expected because there's a latency in converting the Hive scripts into MapReduce scripts. And the features of Hive: first, it supports different file formats, including sequence file, text file, overall file format, ORC file, and RC file. It also stores metadata in the Rdbms, and it provides numerous compression techniques like snappy compression and gzip compression. It also allows user to write SQL-like queries, which will be converted into MapReduce tasks or Spark jobs to query against Hadoop datasets. And the fifth one, users can plug in MapReduce scripts into the Hive queries using the UDF user-defined function. And lastly, it can perform specialized joins that help to improve the query performance. So the differences between Hive and traditional RDBMS: first, Hive allows schema on read, which means that the component can be inserted, that users can which allows the component to insert data without checking for the type or schema definition of the table. It also verifies the data only when the data is read from the table. However, traditional RDBMS includes verifying if the data is inserted as per the table definition and schema definition during the write phase itself. So this is how RDBMS databases like SQL or Oracle Server works. And the second one, Hive allows you to store hundreds of petabytes of data because it stores data in HDFS, which has a scalable storage space. On the other hand, DBMS has a max storage capacity of approximately 10 terabytes of data. And lastly, Hive does not support ILTP, while traditional DBMS supports it. So data types in Hive, actually there are two types, the simple and complex, but in this opportunity I will only discuss the simple. So first we have integer, tiny integer, small integer, integer, big integer. What differentiate is only the storage capacity that it holds. For tiny integer it's 1 byte, small integer 2 byte, integer 4 byte, and the last big integer is 8 byte. And then we have float, which stores 4-byte floating point numbers, double 8-byte floating point numbers, and string, as we all know, sequence of characters. And then we have the collection data types in Hive. There are three. That can you scroll? the map, struct, and array. So basically, map is a collection of key value tuples. Elements are accessed by passing the key. Here we have the key 1, 2, 3, and the value GG Arkan Dava. And if we access the name string, we have the value of Dava. And then struct is a collection of data type where in the fields are accessed using the dot operator. So here we have a variable struct called name, and we already specify the first and last, which are string, and we can access by using name dot first. And lastly, we have array, an ordered sequence of the same type of element. The element is an array can be referenced by pressing the index. So here we have names, an array of string, and if we output the names with index 2, it will output Arkan as it starts with the index 0.
Okay, thank you very much, Gabriela, for presenting the background information about the platform. And now I'll be talking about some of the implementation of the Apache Hive. So firstly, I'd like to talk about tables. So we have two types of table. The first one is the managed table, and the second one is the external table. So I'll first talk about the managed table. So the managed table can be created using the statement create table name. So it's pretty similar to the SQL queries. So the syntax for creating managed table is highlighted as below. So for example, we have create table name, and then bracket column 1, and we specify the data type for column 1, column 2, again the data type as well. So it will go on until we we define all the necessary columns within the table, and then after we close the bracket, we put a row format, delimited fields terminated by, and double quotation mark stored as text file. So what the double quotation mark means is that each of the fields are going to be separated, in this case by an empty string. And the second one, I'd like to talk about the external table. So an external table can be created using a similar statement, but there's just a small difference between the previous one. So we have create external table name, and then the example for the syntax is create external table name, and then the same as before, specifying all the columns and the data types, and then row format delimited fields terminated by double quotation mark stored as text file. So I've shown the example for both of the statements for creating the two tables. And then after that, I would like to discuss about the differences between the managed table and external table. So let us have an example about the delete statement on the external table. So for example, we have the statement delete statement on external table metadata data. So the above instructions aim to drop an external table. So when we drop an external table, only the metadata is removed. In other words, the underlying HDFS directory will remain intact. So why do we do this? Well, it allows the users to manage the HDFS files and directories and the external table because they don't get removed. Meanwhile, let's talk about the other delete statement on the managed table. So delete statement on managed table metadata data. This second instruction aims to drop a managed table. And the difference between dropping an external table and a managed tables is that if we drop a managed table, both the data and the metadata are removed, and hence the underlying HDFS directories or data are also deleted along with the metadata. And because we delete both the metadata and the underlying HDFS directories, hence the name managed, because both of them are taken care of in a single instruction. Okay, moving on from table, I'm going to talk about how do we insert data within a Hive table. All right, so the insert statement is similar to that of the SQL statement. So it's used to insert values in a Hive table from a local Unix file or HDFS file, or any data from the other Hive table. If necessary, hard-coded values can be inserted into a Hive table by specifying them directly in the queries. So we have four types of sources. We have HDFS file, Unix file. We can also insert data from Hive table, another Hive table, and we can also insert data by hard-coded value. So as you can see, there are four types of instruction depending on the data source. So I'm not going to talk about that. And then let us talk about how do we update data in the Hive table. So update, similar to the SQL query, is used to update certain values or rows of the Hive table using certain conditions. So this statement is available for the Hive version of 0.14 or above. And you can see how we use the update statement as shown on the screen. So updates table name, set column equals to value, where expression. And then next, I'm going to pass on to Arkan to talk about the queries and the alter statement.
Okay, thank you, Deva. In this case, I will explain about the query of the Hive table. Querying in the Hive table is actually quite similar to in SQL. So basically, just type select column, and then from, where, group by, order by, and limit. The explanation is select is the clause that you can specify to the column that you are going to retrieve. From table name indicates the Hive table from which we are going to fetch the records. Where is the condition part? Group by is used if we need to group the record based on certain column value. Order by clause is used to sort the rows based on certain conditions. Limit is used to limit the number of records being fetched during every retrieval. And then the next we have alter. Alter statement is used to change the name of the Hive table. In this case, the query is alter table, table name, rename to, and the new table name. Then we have the so the example is like this. So I have a table before called employee, and then I rename it to employee underscore org. And then on the next, the alter statement can be used to add column to an existing Hive table. With query alter table, table name, add columns, and with new columns, data type, and so on. And then we have, and then alter table could be used to replace columns in Hive table in query like alter table table name replace column with the same format as the add column. Okay, so delete. Delete statement is used to delete certain rows from table based on condition using where clause. This is the example of the delete. So we use delete from table name and the square bracket. Inside is where expression. Then we have truncate. Truncate is a statement is used to remove only data from the table while the data structures remain intact. So in this explain, the query is truncate table name. And then the next one, the last one, we have a drop statement is used to drop the table altogether. The query is drop table if exists table name. The use of the drop table is quite similar to what Dava has explained before in delete. So in manage Hive table, drop table operation only remove both metadata and the data itself. The data will be moved to trash directory while the metadata will be removed permanently. And for the external tables, drop table operation remove metadata information, but the data will remain intact in the HDFS directory. I think that's our presentation. So thank you very much for the presentation, for the time.
Okay,
That's
thank you
all.
very much.
Okay.
Do you any additional presentation or something?
No, that's
No.
the end of the presentation, sir.
Okay, thank you. So I have one discussion or one question.
Okay.
What do you think about the Hive? Is it is proper for like data warehouse facilities in the big data, or just data storage in the big data?
Okay, I'm going to answer the question. So we talked about the advantages and disadvantages of Hive. So it depends on the type of business that you're doing. If you're doing like an online transaction in which real data query is needed, I think Hive it's not appropriate because there's a latency in converting the instruction into MapReduce. But however, if you're doing it for like an analytic processing and you want to scale the project such that it's not you can scale it up and down, I think it's appropriate, and also it's appropriate for SQL users as well, because the instructions, as we've demonstrated, are most of them are quite similar, so they don't need to adapt to the new language. So yeah, it's just not appropriate for real-time processing.
Okay.
But apart from that, it's more than it's more than good. I think it's a great platform to be used for analytics processing.
Okay, thank you for the answer. It's good presentation and excellent for the team. Thank you very much.
Thank you very much.
Yeah.
Yep.
We go to the next team. Yeah.